Hi guys, welcome to Techogenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello all, welcome to the Techogenius Academy. Today we are here to discuss the next series of Internet of Things. So we have uploaded the series of Linux device driver, embedded Linux on BeagleBone Black, Linux system programming, and various stuff in data science or Elasticsearch and all. So that went so well. So we were getting the request of uploading videos and some sessions on Internet of Things. So we thought of some concepts to discuss with you and share our knowledge. So we are the IT experts, and I'll not go into the description and explanation of what is this Internet of Things and in deep whatever the advantage and all, so that you can find out over the internet and all. So basically this series is of next 6 months. So the next 6 months we will mostly concentrate on what are the different technologies is used in the Internet of Things, and we will try and we will use those technology in the real time, and we'll try to have some projects on that and how we can communicate with those services, as we can say in a simple layman language. So without wasting any time, let's get started. So the today's schedule is I will just give you the overview of what is actually Internet of Things and what is the usage, where exactly on which industry this IoT things currently using, and then I'll directly jump to that IoT stack, where we will come closer to that layers of IoT, which will help us to communicate between the devices and the cloud applications. So we will go to the cloud platform too. Then I'll just explain a little bit about the cloud computing, because if we are talking about the IoT, then cloud will definitely come into the picture, and we will see that what are the different ways where we can approach the cloud for the data collection and the management. So, and the last thing will be the management, and what are the next steps which will we use in the next 6 months. So the next thing is probably we will try to involve as much as technology as well as the platform which is readily available in the market, and probably we will look into that. So without wasting any time, I'll just jump into that Internet of Things. Yeah, so the overview of the Internet of Things is like the ever-growing network of technologies connecting and communicating via the network to send and receive the information without involving the human-to-human interaction. So this is the very basic definition. So we it's like when I'm sitting in front of some person and I'm conveying some message to him or her, then it's like a human-to-human interaction. But when we are dealing with the network, or when we are dealing with cloud and all, so there is no interaction with the human, and we can send the information via communicating with the network. So that type of a technology and the connection will come under Internet of Things. So in a simple language, we can say it's a Internet of Things. And IoT consists of the industries where IoT is used is energy, water, smart homes, building, agriculture, healthcare, military, waste management, etc. So we are mostly into these industries. So actually there are more industries also, but it depends like what are the requirements we are using, what are the requirement in the particular industry. So based on that, we need to use some devices in that IoT. So basically the IoT consists of sensors. So as I was explaining you that based on the industry we need to use sensor devices and all. So IoT actually consists of that sensor devices, gateway, software applications, communication protocol, network server, and the cloud application. So you can say that IoT technology is divided into 5 layers, where you can say it's a full duplex communication, and we can say it's a IoT stack. So in IoT stack, the first thing which will come is a device hardware, as you can see, or we can say it as a tags also. So the device hardware is actually the basically basically having the tags which is having all the sensors connected to that required for that industry, and there'll be SoCs also like BeagleBone Black, Raspberry Pi, Arduino, NodeMCU, Semtech, etc. Readily available in the market, which will be used in the IoT industry. So if when I'm talking about tags, it means like what are the different sensors used for the particular product. So that will be used here. And suppose like if you are if your product is wearable, like a smart watch or something like that, so there'll be motion sensor, there'll be a GPS sensor, so there'll be accelerometer sensor, there'll be a temperature sensor also, humid sensors kind of thing. So these kind of sensor will be available in your device hardware. Now the next thing comes into the picture is the IoT gateway, which we call it as a device software also. So an IoT gateway performs important role in IoT solution, like you can say translating a sensor data or messages to that encrypting data. So to that encryption, suppose some data, some sensor data you are sending to that cloud from the device hardware. So the IoT will give more security to that data and manage the data, and you can say filter the data and send it to the cloud. So you can say also it's the glue between the cloud application and the end devices. So the cloud application is the end last part, where you can say it's end user application which user can interact with. And so the IoT gateway can perform high scalability, it will lower the cost, it will fast the production, and it will reduce the risk of causing the big problems, where it will add the you can say the layer of security to that. So basically the IoT gateway is useful for that. Then in later stage communication will come into the picture. So now if you are sending some data from the device hardware, and after that it will go to the gateway, now we need to communicate to the cloud applications also. So that communication is the way you can say that how your device will share the details of the sensor data and information to that cloud, and vice versa. So vice versa means it's a full duplex communication. So any data which you are sending from the device hardware to the cloud, and this data which cloud also can send to the end device or tag. So the both ways can be possible. So IoT stack is a full duplex communication. Now, so mainly IoT solutions used MQTT for the communication. So MQTT is a message queuing telemetry transfer protocol. Okay, so it's a, you can say it's a publish subscribe system which is used in a IoT solution. And most of the people in IoT and or any in projects and all, so they are using this same thing. And UDP also, TCP, UDP and all this communication also is useful to send the data. Okay, so we will use UDP also for the communication. Now the next thing is the cloud platform or the network server. So as in the market there is many cloud platform. If you are aware of Chripstack, the Things Network, Azure, definitely the for the cloud computing and all. So the what all are these platforms are. So the cloud platform is the backbone of that IoT solution, which will support data collection and the management. So we have to make sure that how much data is collecting and managing and all thing. In this there'll be a cloud APIs which will help us you to connect devices and share data from the device to cloud, and from cloud to the end device, or you can say tags. And in this cloud platform, analytics also will play a very important role. So how you're managing the data, how much data it came and it stores and all. So based on that, based on the analysis, you can predict something, your analysis and all these things. In stock market also it can be used. So this is the thing. There are so many companies which using this platform and all. And later on the cloud application will come into the picture, and the cloud application is nothing but your end user application, as I have already said, which is a part of your system, and which you can interact with. So these application will be like web based. So whatever the data you are sending, you need to showcase to the end user. So what are the types of those applications? So that can be a web based. Okay, so there will be some website where you are showing your details and all. There can be a mobile app, mobile based also, or the wearable. So as I have already said, you the smartwatch, as per the requirement of that product. So it depends like what kind of product you are approaching to. Okay, so this is the basic understanding of IoT, that how we are dealing with the different layers of Internet of Things, and what are the different industries where IoT is being used. So the next thing I would just want to show that IoT Stack. And IoT Stack, like what we have discussed right away. So now in this thing, like there are so many companies, as I already said, that Things Network is there, Chripstack is also there, which will give you the IoT solutions for that. Okay, so we will go one by one, that what are the different things we will use for this IoT stack and all, and we will go deep into that also. But today, like, I'll just showcase you that what are the things we will use in next 6 months. So the device hardware which we'll use is Semtech microchip boards, and BeagleBone boards, BeagleBone Black, Raspberry Pi, NodeMCU, Arduino boards and all. So we will use these boards for our IoT solutions. And the Things Network, as I have already said, it will be the building block of giving you that LoRaWAN and network. Similarly, Chripstack is also will give you that same. So it will provide you the LoRaWAN network server stack, and it provides the open source component for that LoRaWAN. So if you're not aware of that LoRaWAN, so LoRaWAN is the technology used in this IoT solution and all. So LoRaWAN is a low power wide area network protocol to communicate with internet connected application over long range wireless connection. So the architecture of the LoRaWAN consists of gateways, network servers, and the application servers. So there are RF chips also which will be available from that Semtech used to transmit the sensor data. Now as I have already said, that in a LoRaWAN architecture there is end devices, gateways, servers and all. So let me just go to that another tab and showcase you LoRaWAN. Okay, LoRaWAN gateway. Yeah, so you can have good understanding of what is actually the LoRaWAN and all these things. So things network is also there. So this is devices. Yeah, so this is the architecture. So as I have already explained you that there is end devices, gateways, network server, application servers and all. So the end devices like the pet tracking, smoke alarm, water meter, vending machine, or some trash container. So this end node is basically the sensors, and the sensor data will go to that concentrator, or you can say the gateways, and the gateway will interact with the network server. So via it says like TCP IP SSL LoRaWAN connection. So the LoRaWAN is based on that RF, because there is a RF chip connected to that LoRaWAN, and it interacts with the network server, and the network server will send those data, and the payloads, we can say that payload in terms of this server interaction and all. So those data will send to that application, so which user can interact with. Okay, so this LoRaWAN architecture, so we will study more about that as it is explained here also. The piece of an object with an embedded low power communication device. This is the end devices. Gateway, that is antenna that receives the broadcast from the end device and send data back to the end device. So as I have said, it's a full duplex communication. Network server is serves that route messages from that end devices to that right application and back. And application is a piece of software running on the server. Okay, so the cloud application will run on the cloud platform, which whatever we are using. Similarly, this is the technology, and as I have explained you that about that things network. So the things network is like it will provide you the solution to that LoRaWAN network, and also whatever the cloud platform or application you want to use. So you can use this things network, or any sensor data if you want to send, so you can send to this and interact with, or vice versa. So from the things network also you can send the data to that end devices. And similarly, there is a Chripstack also. So Chripstack also, it's an open source LoRaWAN network stack where it is divided into three parts. There will be a application server, there will be a network server, and there will be a gateway bridge to that. So we will look into that. Okay, so the gateway bridge actually handles the communication with the LoRaWAN gateways and all. So whatever the gateway data it will come, it will go to that gateway bridge, and from the gateway bridge we have the communication protocol added to that, like MQTT and all, which will send those data to the cloud platform, and from the cloud platform we will showcase to that application, so which user can interact with. Okay, so how to create these applications and all, so we will look into that. So if you have time and all, so you can go to this gateway bridge and all, so you can look into this thing. So there is MQTT broker. So MQTT broker is also there. So MQTT broker which we will use is a Mosquito. So this Mosquito broker we will use for our communication and all. Okay, so let me just go back to here, and we have discussed about the device hardware, the things network, Chripstack, LoRaWAN technologies, and the communication protocol also. So as I have already said, it's a publish subscribe system. So there is one topic where you can say the one user has to send some data to that particular topic, or want to like it will just publish some message on that particular topic, and in the other end the other user will subscribe to that same topic for receiving that messages. Okay, so how it will be done that in the gateway bridge we have that MQTT broker will be there, and whatever the sensor data information come from that end device to that IoT gateway, and from gateway to that bridge we will receive that. after the encryption and all these things, then probably we will send those data to that particular topic, and the cloud platform, we have that application set up over there, and we will receive from that. Okay, so we will use that, and UDP also we will use for the communication and all to store that data. So now the next thing will come here is a database. So earlier we were using for storing some small data, we were using IoT I2C protocol like EEPROM and all, but here we will use SQL database for storing our data. So we will use the JSON format for that, and what will be the payload, what will be the maximum size for that, and there is some values which will be restricted to the particular sensor data. So we will see, and we will just store into that database. So I'll make some sessions on that, on the basic session, like the basic session for how we can open the database, how we can write to that database, and how we can read that. So we'll look into the database sessions too. And the next thing which will come here is that testing tool. So just see, like suppose we are sending some end node device, the sensor data to that cloud. So we need to check like whatever the sensor data we are getting on that topic, so is that correct or not. So we need to check that format is correct or not, and everything. So before uploading to that application server, so for that we will use Postman. Okay, and later how we are using this application, that gateway bridge and all these things, we will put into that Docker. So now Docker and Kubernetes is very important, and most of the people in the IT industry are using Docker and Kubernetes. So what actually Docker is, so I'll not give you the detail and all, so I'll give you the basic information about this, what is actually the Docker and Kubernetes, and later on, like separately, like we will deep dive into that Docker, and we will use the Docker images to build our IoT solution. Now Docker is an you can say it's an open platform for developing shipping and running applications. So this I have taken from the internet, and this is very good. So it's like suppose you're working on some project. Okay, so you are in the developing stage and all, so you tested your application, it's working and all, so like your team has tested all this thing, and you have just uploaded, and you have just sent those details to that client. So when it jumps to that production stage, and when they are testing on their system, it fails. So you are wondering that why it is happening. So because whatever the application you are running over there in your system, it was actually working fine, but it was not working on the production side and on the client side and all. So what was the reason and all? So that is like unpredictable stage where you can't predict like what is happening over there. So it's like wastage of time and all. So here comes the Docker thing. So whatever the applications we are writing and all, we need to put it into some container. So the Docker is nothing but it's a container kind of thing. So you have to create the image, and that same image you need to pass it to that production site, and they have to run that image. So that will definitely work. So the Docker enables you to separate your application, means like in the simple language. So the Docker enables you to separate your application from your infrastructure, so you can deliver software quickly. And with Docker you can manage your infrastructure in the same way you manage your application. So by taking advantage of Docker methods of shipping, testing and deploying the code quickly, you can just reduce the delay between the writing the code and running into the production. Okay, so this is basically the Docker, and we will jump into more details and all, is like how we can write the Docker file. Okay, so now here comes the Kubernetes. So Kubernetes also we can use, we are using in the IoT solution. So the main thing behind the Kubernetes is the okay. So how I will explain. So the main thing is about the Kubernetes is the Kubernetes cluster service. Now in the Kubernetes we have different workers. So worker are nothing but it's a container host that communicate with the cluster. So in worker there is a kubelet process runs which helps to communicate with that cluster service, that Kubernetes cluster service. Now suppose like all this configuration of this cluster service sits in a some YAML file. So that YAML file is basically the deployment file. Okay, and the major part is in it's a pod. Okay, which is the smallest unit of the deployment in the Kubernetes. So like in terms of Kubernetes object model, this pod we in this pod we can have a running containers. There can be one container, there can be a multiple container also. So those containers we will put into that worker and all. Now suppose we have multiple workers and all, in between if some of the worker we are not using, so that will drop out. Okay, so if suddenly if it fails, then what will happen? Like in Docker also, like if we are if we are using one container and in that container we have that application, and for that application there are multiple instances for that. Now just suppose there are multiple instances for that application. Now somehow that container lost that connection, so we can't access that container and all. What will happen to that instances and all? What will happen? So we can't access that. But in Kubernetes the solution is in the Kubernetes. So if there are multiple containers in that, so if any of the containers goes down, we can access we can't access from the cluster, correct, but we can access from the another worker. That instance will be saved into that another worker. That is the you can say that is a good point in Kubernetes. So we that is a good solution where we can achieve that other instance also from the other worker, or you can say another container. So this is the basics of the Kubernetes and all. So but how we will use this Kubernetes into that our IoT project, so we will look into that definitely, and step by step we will jump into that. And after that the cloud computing comes into the picture. So the cloud computing, okay, before going into the cloud computing, you know about that I'm thinking like you're just aware of this cloud platform. So what are the service they provide in the cloud platform and all. So basically we will use Azure IoT. So this is also Microsoft Azure. Yeah, we already know that they are providing you the solution, or they are providing you the service to make your IoT solution or your IoT product. And like you have to decide like for how much time you want to use. You can avail for that service, and whatever if your things are done, then you can just release that for the other use, like for others to use. Okay, so as I was explaining that we have services in the cloud platform which are like infrastructure as a service, platform as a service, software as a service. So we have those services. In infrastructure as a service, like it's a basic things to use, like what application you have to run, what binaries you have to use, what programming languages you have to use and all. So that will come under the infrastructure as a services. In platform as a services, like it will be the ready to use platform where the platform will be provided to use, and you can just dump your application over there, and you can do whatever the changes you want to do in the application, and you can do that. So and the third one is the software as a service. So software as a service is like the complete software is given to you by the cloud, by the Azure, so you can use. As there is a Azure in Azure there is a Azure IoT component also, where the Azure IoT Center will come, which is basically use the SaaS kind of service, which is, I can say, the software as a service. And there is a IoT solution accelerator, Azure IoT Hub 2 is also there, Azure Digital Twins, Azure Sphere, Azure Maps. So there are multiple things present in Azure IoT. So we will mostly concentrate on Azure IoT Hub, which let you connect to that other service and applications. And we will go deep dive into this Azure IoT. So these are the stuffs which will just look into. And now what next? So what next is like I will use some device hardware. Yeah, so I will use some device hardware like BeagleBone Black, Raspberry Pi, or any NodeMCU. So after that, like we will use some communication protocol also, like MQTT and all. So first I will explain you that what actually MQTT is like, and how we can use it, and the coding part actually we will look into that, like how we can publish and subscribe to that particular topic. And later on we will use some of the device hardware, and we will send those information to that things network, or you can use the Chripstack and all this thing. And when we completed and we understood the stuff, then I'll add some database to that. So if I want to store some data which is coming from the things network, and things network to that end devices and all, and we need to store into some database and all, so we will do that. And surely we will use some Postman and all. Then when we will jump to LORAWAN technology, the Chripstack and all, so then we can add more details, then we will jump to that pure IoT stack thing. And definitely we will provide the good solution to the IoT. So yes, if you like this session, please do like, share and subscribe. And if you have any colleagues, those who want to learn the IoT things, please share with them. And yeah, thank you so much. So we will meet in the next session, where we will try to have some fun with the devices and all.